right now. An answer which has equation that has complex roots. You could solve this using our knowledge of algebra.
Mm-hmm.
Which z cubed minus 1 equals 0, and then you factor out z1, so it's the difference of cubed. You get this. Therefore, you get z is 1, we know that, that's okay. And we also can get, using the quadratic formula, z minus 1 plus or minus the square root of, yeah, I'll just tell you what it is, minus 3 over 2. And that means we have our minus 1 plus or minus 3 over 2. Okay, so that's okay. Now we're going to look at these diagrams then, and then we'll talk about the answer. Okay, first of all, we can see that there's two conjugate roots here.
Yep, that makes sense.
Yeah. All right. So let's sketch. So 1 is here. That's Z1, I suppose we call it. Z2 then would be, well, let's take Z2 as minus root 3i2. So it's going to be minus a half minus root 3 over 2. So somewhere here. Okay. So that is Z2, and Z3 then would be its conjugate. So what would the conjugate look like as a reflection? Where would a conjugate reflect?
It's reflected across the horizontal axis.
There we are. Yeah, maybe so here. So what we have these positions of these three. We could also look at these in modulus argument form, which starts to create that angle, doesn't it?
Yeah.
So let's take just Z2 for example. The modulus of Z2, if I want to keep this, it's going to be minus a half squared minus root 3 over 2 squared. What's that going to give us a modulus? We already think.
What was that going to be? That was.
So it's going to be 1/4 plus 3/4.
That's just 1.
1. Okay, so that does make sense that it would have the same modulus as this one.
Yeah.
So they're all equidistant from the center. So they're all on this. They're all on the unit circle, really, are they? For this particular example, they're all 1.
Yeah.
1 over 8. All right, so that's we could draw a circle and you don't have to. All right, so then you are looking at the angle that they create, because you can just look at this negative half is going to refer to, well, what's the cos of theta that gives negative a half. What is cos?
Cos of theta that gives negative a half is negative. Wait, which we're going that way. So the one that's negative a half is going to be that way. Wait, are we doing it between negative pi and pi, or? Yeah.
This one here, yeah. So this angle is going to be then negative.
That's negative.
That's just 2 pi over 3, isn't it?
Yeah, yeah.
Double pi over 3. Okay, because it's in that quadrant. Okay. And this angle then would be the opposite of that.
Yeah.
Yeah. And therefore, the remainder part of the circle is 2 pi.
Also that.
Yeah. Okay. So what happens when you take this as a solution and you multiply it by itself 3 times? Where do you end up?
Just Z2?
Yeah, so you multiply Z2 by itself 3 times because it is a solution to this equation. Where does it end up?
It's going to end up, it's because when you cube it, that's the argument gets multiplied by 3, so it's gonna end up at 2. Wait, it's gonna
2.
end up, yeah,
1.
yeah, that's what I mean.
Yeah, so when you multiply it once, it's going to be, the argument's going to be 4 pi over 3, and when you multiply it again,
It's going to be,
back here.
yeah, it's going to be, yeah.
So, yeah, so therefore, it as a solution, it is a solution because you've just done it. Because the modulus is still going to be the same.
Mm-hmm.
And when we work, so it's going to be at 1 based off angle multiplying 3 times. And of course, the full circle would be 2 pi over 3, wouldn't it? In general, to do that full loop around. So to do it in 3 steps, it'd be z cubed.
Yeah, okay.
So does that work? So the question, I suppose, is always then, does that always work? So if I had z to the 6, for example, or z to the 5, is it split up into 6s?
Yeah, it would be, just because, yeah.
Yeah, it should do. Well, let's just do a quick confirmation case. So let's do this one. Okay, so let's get this in modulus argument form instead of doing it the other way, because it's going to be a little bit tricky to do it the other way. So modulus argument form, and then we'll use the Moivres just to make sure that this all works out nicely. So, can you talk me through what's that in?
Well, the modulus is just going to be 64, and the argument is, well, it's a real number, so the argument's going to, but it's negative, so it's negative. No, sorry, the argument's just pi, right?
Yeah, we might lose internet connection. Are you still there?
Yes, I'm still here.
The internet will probably go in about 5 seconds because we just lost power.
Oh.
That's happened already today. Okay, so if I wanted to say, so what did you say it was? Pi? 2 pi?
Yes. Just pi, isn't it?
Just pi, yeah. So cos pi. So we need to get the 6th root. So, cos pi plus I sine pi. Huh?
Yep.
Use cellular data. So switch. You're still there?
Still here, just barely.
All right, no, you see, I had to switch to my cell phone data. All right. So the 6th root of 64 is?
2.
2, yep. And then what we put here is a general form for the, what would I write?
Pi plus 2k pi, right?
Cos pi plus 2 k pi divided by?
Divided by 6.
Yes. Okay. All right. And we have plus I sine, yeah, whatever. Pi plus 2k pi divided by 6. Okay. All right. So that's the general form. Let's get some answers for this. So let's do when k is 0. So when k is 0, what do we get? We get pi over 6.
We get, yeah.
For z1, we're going to say, so that's 2 cos pi over 6 plus I sine pi over 6. What's that as a Cartesian?
That's root 3 plus I. Root 3 plus I, right?
Oh, yeah, because you've already divided. Yeah, so that'd be root 3 plus I, yes, because over 2 and then multiply it by 2. Okay, so let's look at that. Is that position starting to make, does that position make sense?
Yep, I think so.
Yep, so that'd be somewhere here, wouldn't it?
Yeah.
Yeah, root 3 plus I. And if you multiplied it 6 times, wouldn't it reach here?
Yeah.
But it would be starting to move further and further out because its modulus is not 1.
And it would eventually get to 64.
Yeah,
but...
get to 64. Yeah. Okay. Yeah, so it is making sense, and the angle is directly. I don't know. Is that the question answered?
Well, I mean, basically, yeah. It's just because it makes sense that it would be, yeah.
Yeah. Okay. Okay. Well, I think, yeah. I don't. Yeah. I don't. I think
it wasn't a very clear question in the first place, anyway.
Yeah, but it is. No, it needed perhaps clarification. Better than I gave on Friday. So that I needed some example questions just to do. Yeah. So yeah, the conjugate in general is the reflection across the real axis, and then it, in these particular cases, for the reason the theorem works. Well, we can see the reason the theorem it works because it's splitting, it's multiplying by itself 6 times.
Yeah.
And for the argument, it's multiplying by itself, and that's you end up in the correct position for the solution, and that's why the conjugate works, because it'll bring you to that correct position from either direction.
Yeah.
Okay. All right. It's proof by induction, contradiction, and what's the other one? Proof by induction, contradiction, and
Direct proof.
Yeah. Yes. So it's mostly just induction and contradiction.
Oh, okay.
The direct, no, there is direct proof. Yeah, question 2 is a direct proof. Yeah, so get on to those, see how you get on. Question 5 is maybe a bit tricky. The other 4 should be okay.
Okay.
But we'll go through all the answers to those tomorrow morning. And if you want to add some from the textbook, do the same.
Yep, I will.
Did you do complex numbers? Did you do any extra ones, or
I didn't. I felt pretty good about complex numbers, I think.
Yeah, I think you were.